All right. Next section, section 6.2, we're going to be talking about inverse functions. Inverse is just a fancy way of saying undo. Inverses mean undo. So we're going to be finding an inverse and checking to see if two functions are inverses. We're going to be using three methods. First, equations. Second, graphs. Third, tables. So starting right here, I've got this function. F of x is equal to the square root of x minus 3. All that minus 2. How do I undo this to find x? In other words, how do I find an inverse? So if I have to find the inverse here, I want to go backwards to find what the x was. So to do this, no problem. I'm just going to solve for x. Now some people say switch the x and y and solve for y. Either way, it's the same process. I'm just going to solve for x. So I'm going to say, first thing to solve for x, I'm going to get rid of this 2 here. I'm going to add 2 to both sides. Y plus 2 is equal to the square root of x minus 3. Next thing I'm going to do is because I've got to get rid of the square root right here, I'm going to square both sides. And I'm going to get x minus 3 is equal to y plus 2 squared. And then I'm going to add 3 to both sides. So x is equal to y plus 2 squared plus 3. I'm going to flip it around here. And because I do want to graph it where I have y as a function of x, I'm going to switch the letters now. Y is equal to x plus 2 squared plus 3. So the question was, how do I undo this to find y? I'm just going to do all the operations that go backwards. Just going backwards one at a time. It's just doing the order of operations backwards. So normally I'd start in parentheses and then move to addition subtraction. I started with the addition subtraction. Then I dealt with the exponents. Then I dealt with what was inside the parentheses. Just going backwards. That's all you have to do. That's it. But because inverses are written like this, we're going to write f to the negative 1 of x is equal to x plus 2 squared plus 3. And that's how you write the inverse of f. That's all you got to do. Let's do another one off to the side here. We'll just do a nice linear equation. 2x minus 5. So that's really the same as y is equal to 2x minus 5. So I want to go backwards. What if I want to go backwards or invert it to find x. So first thing I'm going to do is add 5 to both sides. Y plus 5 is equal to 2x. I'm going to divide everything by 2. So x is equal to y plus 5 divided by 2. And I'm going to switch the letters here. Y is equal to x plus 5 all over 2. Now that's the answer, but I'm going to write it as f inverse of x is equal to x plus 5 all over 2. That's how you find it with equations. We're going to look at the graph of this in just a moment here. But here's how you find it with equations. Just switch the x and y and solve. So the steps are, most people do it this way. Switch x and y, then solve for y. I did that in my last step. Process is still the same though. We're just trying to undo it, go backwards. All right. Next we're going to see is I'm going to be showing you a graph here in just a moment of how you can find an inverse graphically. All right. So I did this on Desmos. I graphed both of these. And you'll notice that they have the same shape. Only there's a big difference between them. They're reflected. And what are they reflected over? Well, they happen to be reflected over the line y is equal to x. So another way, if I were to give you just the line here, y is equal to square root of x minus 3 minus 2, like I did before. If you want to find the inverse of this graph right here, flip it over the line, y is equal to x. You'll notice all these points right here are perfect reflections. This is point 0, 7. You'll notice this point over here is 7, 0. This point right here is 3, -2. This point up here is -2, 3. And it just continues on like that. So graphically, if you have to find an inverse, flip it over the line y is equal to x. That's all you got to do. Pretty simple. Take all the points here, switch the x and y, and put it up here. Which leads perfectly into how we can do it using a table. All right, so if we need to find an inverse graphically, all you have to do is reflect that function over the line y is equal to x. And when we do, you're going to find that all the x-coordinates become the y-coordinates, and all the y-coordinates become the x-coordinates. That's going to lead us right down here. So we just learned the y-coordinates become the x-coordinates. And the x-coordinates become the y-coordinates. Well, that leads us right into this then. If I have to find the inverse of this function, and this is the function we just used, f of x, if x is 3 and y is -2, then that means the inverse is going to be -2, 3. If the x value is 4 and the y value is -1, then the coordinate's going to be -1, 4. Same thing here, 0, 7, 1, 12. And we could see that from our graph. If we look at the graph, we'd be able to see it follows this exact same pattern. So if you got a table and you need to find the coordinates, just switch them. That's all you have to do. Even if it's written like this, even if it's given to you like this, function is 2, -3, and let's say 5, 12. The inverse of that is going to be -3, 2, and 12, 5. That's all you have to do to find the inverse if you're just given a table. Remember, we're just undoing it. We're switching. We're going backwards. So if I was at 3 and I ended up at -2, the inverse says go backwards. Well, it means I start at -2 and I go backwards to 3. If it was at 4 and I ended up at -1, well, go backwards. So I'm going to start at -1 and go backwards to 4. That's all inverses do. Inverses just mean undo it. Go backwards. So, how can you check if two functions are inverses? First way to do it, right here. Just look at the numbers. If the x-coordinate and y-coordinates are switched, then you know they have to be inverses. That's the easiest way right there. Look at the graphs. Same thing. If they're reflected over the line y is equal to x, you know it's an inverse. That's the two easy ways to find inverses. if it's graphically or with tables. To find an inverse using equations, though, we're actually going to have to plug some things in. So here's what we end up with. So I'm going to start with the equation, the one we used earlier here. F of x is equal to 2x minus 5. And what if I were told g of x is equal to x plus 5 all over 2? And I have to check to see if these are inverses. Well, if I invert a function, I should end up right back where I started. So I start with x, and I do a bunch of stuff to it. And then if I undo that stuff to it, I should end up right back at x. So here's the thought. I'm going to plug g of x into f of x, and if I end up right back at x, then it's an inverse. So f of x, f of g of x. Oh, we just did this last time. That's right. I'm going to plug it in here and see if I end up, is it going to give me x? That's the big question. If I do something to it and then undo it, I should end up right back at x. So let's try it. F of, instead of g of x, I'm going to plug in x plus 5 all over 2. And if I plug in x plus 5 all over 2 into x, well, f of x is 2 times x minus 5. So I'm going to plug in x plus 5 all over 2. And if it gives me x, then we have a winner. Now let's try here. So when I multiply this 2 times the 2 there, those are going to cancel out. So I'm going to get x plus 5 minus 5. And that's just going to give me x. Great, but that's not enough. Got to check the other way too. G of f of x. Now normally this will be pretty quick to check both ways. But same thing. Got to check, does this give me x? That's the big question. Well, let's try it. G of f of x is 2x minus 5. So I'm going to plug that into my g of x, which is x plus 5 all over 2. But instead of the x, I'm going to plug in 2x minus 5. Well, those cancel out. And I'm going to get 2x all over 2, which is just equal to x. So that one works as well. Nice, easy way to check if they are inverses. Just plug them into each other. If you end up right back where you started, which is x, then you know it has to be an inverse. It even works with square roots. If f of x is equal to the square root of x minus 3 minus 2, and I'm actually going to put a plus or minus on here. And if g of x is equal to x plus 2 squared plus 3, if that happens, then if f of g of x is equal to x, then I know it's got to be an inverse. Well, let's try the first one here. F of g of x is equal to f of x plus 2 squared plus 3. So let's plug that in here. Plus or minus the square root of x plus 2 squared plus 3 minus 3. That's just the g of x right there. I got minus 2. Well, let's see here. If I take the positive 3 and the negative 3, those are going to cancel out. I get plus or minus the square root of x plus 2 squared minus 2. Well, if I'm squaring a square root, those should undo each other as well. So I'm going to get plus or minus x plus 2 minus 2. Those cancel out, and I'm just going to get plus or minus x, which, if this is plus or minus x, that means it was going up and down like this, which would give us this graph right there. So we're good there. Let's try g of f of x. So f of x is plus or minus the square root of x minus 3 minus 2. Sorry. I'm going to plug that into my function g of x. G of x is x plus 2 squared plus 3, but instead of x, I have to plug in plus or minus the square root of x minus 3 minus 2. So those cancel each other out. I'm going to be squaring a square root, so that's going to give me just x minus 3. I got the plus 3 on the end, and we have an x. Winner, winner, chicken dinner. There we go. All right. So if you need to check if f and g are inverses, all you have to do, plug in g of x into f of x, simplify it. If it equals x, you got a winner, and plug f of x into g of x. If it simplifies to just x, you have a winner. That's how you can check if two functions are inverses. The only other thing we need to look at here, domain and range. Coming back to the original here. Domain and range, of course, is the x and y. So this is the domain, this is the range of our original function. So if it tells you to find the domain and the range of the inverse, all you need to do is just, of course, switch them. The domain and the range of the inverse. Just switch them. Just switching the x and y's. That's all you got to do. All right. Thanks for watching. Good luck on your homework.